Sir, Shubhodaya, sir. Sir, mute ಆಗಿದ್ದೀರಾ?
Morning, sir.
Good morning, everyone.
Morning, sir.
Good morning, sir.
Morning. So, in the last class, I was telling you about the methods of preparation of dinitrogen. Dinitrogen is manufactured in the large scale, in industrial scale, by the liquefaction and fractionation of air. So, nitrogen can be manufactured in a large scale by fraction and liquefaction and fractionation of air. Fractional distillation of air. As I told you, nitrogen has the boiling point of 77.2 Kelvin and oxygen has a boiling point of 90 Kelvin. So when you liquefy the air, the liquid air contains 78% by volume of nitrogen and 21% by volume of oxygen. And inert gases have a lower boiling point than these. So these two can be separated by fractionation. You go on raising the temperature, so the two are separated. The second method is, it can be prepared by the thermal decomposition of ammonium dichromate. Okay, better you note some of these points, then only you can remember. Note ಮಾಡ್ಕೊಂಡ್ಬಿಡಬೇಕು, ಯಾಕಂದ್ರೆ ಈ ಚಾಪ್ಟರ್ ಒಳಗೆ ಬಹಳಷ್ಟು ಪಾಯಿಂಟ್ಸ್ ಬರ್ತಾವು, ನೆನ್ಪಿಟ್ಕೊಳ್ಳೋ ಡಿಫಿಕಲ್ಟ್ ಆಗ್ತದೆ. Okay, so firstly, dinitrogen can be prepared by liquefaction and fractional distillation of air. Nitrogen and oxygen possess different boiling points. Nitrogen, oxygen boiling point to ಬೇರೆ ಬೇರೆ ಅದ. Nitrogen boiling point 77.2 Kelvin, oxygen 90 Kelvin ಇರುತ್ತದೆ. So separate ಮಾಡಬಹುದು. Second method is by the thermal decomposition of ammonium dichromate. By thermal decomposition of ammonium dichromate. Yes, ammonium dichromate has the formula NH4 twice Cr2O7. When it is heated to high temperature, it will decompose into N2 C Cr2O3 and 2H2O. Ammonium dichromate will decompose like this. So in examination, sometimes they ask questions like this: complete the equation, giving some blank here. This one, or this one. Okay. Identify X and Y and other questions. And thirdly, in the laboratory,
Balancing.
it is prepared by heating a mixture of sodium nitrite and NH4Cl. When sodium nitrite, NO2 and NH4Cl are heated, you have to solution ತಗೊಳ್ಳೋದು. Sodium nitrite ammonium solution ತಗೊಂಡು heat ಮಾಡೋದು.
Sir.
N2 yes
4H2.
Sir, 4H2.
4H2 is balanced here. There are 8 hydrogens, 4 to the 8, and here NH4, 4H2, sir. 4H2. That's a correction. So 3 plus 4, 7. 7 oxygens, and here there are 7. 4 to the 8, and here there are 8. Right? In laboratory, it is prepared by heating a mixture of sodium nitrite and ammonium chloride solution. So it will decompose like this: NN is N2 plus NaCl plus H2O. And we are going to balance NN is N2 NaCl, 4 hydrogens and 2 oxygens, so 2H2O. The equations na ಬರೀತಾ ಹೋಗಿ. So in laboratory, it is prepared by heating a mixture of sodium nitrite and ammonium chloride. Okay. Moving on to the properties of dinitrogen. Properties. Firstly, listen, don't have to write. Equation ಬಂದಲ್ಲಿ ಎಲ್ಲಿ important points ಇದ್ದಲ್ಲಿ ಹೇಳ್ತೀನಿ ಒಬ್ಬರೇ ಯಾಕಂದ್ರೆ dinitrogen is a colorless, odorless, tasteless, non-toxic gas. Non-toxic means non-poisonous, non-toxic gas. Okay. So it doesn't have any color, any smell, and any taste. And it is not poisonous. That is why, it is used in packaging the food articles. Because it is less reactive, it can prevent the oxidation and hydrolysis of the food articles. Okay. So it is least soluble in water. As you learned in topic solution, that depending upon the Henry's constant value, you decide the solubility, no? So highly soluble like carbon dioxide, ammonia, and then oxygen, and then nitrogen. Okay, it is least soluble gas. But under pressure, as pressure increases, solubility of gas, liquid increases. Okay, and its boiling point is 77 Kelvin. Nitrogen has 2 isotopes, that is N14 and N15. Nitrogen ke 2 isotopes are nitrogen 14 and nitrogen 15. What is the difference? It has 7 protons, 7 neutrons, and 7 electrons. This, however, has 7 protons, 7 electrons, and 8 neutrons. 15 minus 7. Mass number minus atomic number is the number of neutrons. So it has 8 neutrons. These are the two isotopes of nitrogen. Nitrogen can react with metals at high temperature to form the respective nitride. For example, nitrogen reacts with lithium, it reacts with magnesium, it reacts with aluminum to form the respective nitrides. Nitrides means just like oxides, nitrides are the binary compounds of any element with nitrogen. Yes, what is the formula of this product form? Lithium nitride as a formula LiN. As lithium has valency 1. Right? So lithium nitride has this formula. In order to balance, I take 2 LiN. Okay. And how about this? Magnesium nitride. Magnesium has valency 2. Therefore, it forms this one, sorry, LiN Li3N. Li3N because nitrogen has valency 3 and lithium 1. This 1 is 3. Here minus 3 and it is plus 1. And in order to balance, I take 3 Li ಅಂತ ತಗೊಂಡ್ರೆ ಬ್ಯಾಲೆನ್ಸ್ ಆಗೋದಿಲ್ಲ 6 Li ಅಂತ ತಗೋಬೇಕು. ಯಾಕೆ ನೈಟ್ರೋಜನ್ ಡಬಲ್ ಮಾಡ್ಕೋಬೇಕಲ್ಲ 2 Li3N ಹೌದಾ 6 Li. Lithium nitride has this formula. Magnesium has valency 2 and nitrogen 3.
Mg3N2.
ಇದು minus 3 ಇರ್ತದೆ. ಅದಕ್ಕೆ ಇನ್ವರ್ಟ್ ಮಾಡಬೇಕು Mg3N2. Magnesium nitride. And in order to balance, we take 3Mg. 3Mg plus N2. Mg3N2. What about this? Aluminium has 3. Nitrogen also has 3. The plus 3 is minus 3. So the formula is ALN. ALN. And in order to balance, we take 2ALN and 2Al plus N2. Note down the equation. Reaction LL ಬರ್ತಾವ ಅವನು ಬರ್ಕೊಂಡ್ಬಿಟ್ಟು ಹೌದಾ ಯಾಕಂದ್ರೆ ಸುಮ್ಮನೆ ನೋಡಿದ್ರೆ ಬರಂಗಿಲ್ಲ ಅವು. So explanation ಏನಿರ್ತದೆ nitrogen can react with metals at high temperature to form the respective nitride. Lithium nitride, magnesium nitride, aluminum nitride. What is important here is the formulas of these nitrides based on their valency. Or valency melinda formula ಏನು ಅಂತ ನೆನಪಿಟ್ಕೋಬೇಕಾಗ್ತದೆ. Okay. Now it can combine with oxygen. Nitrogen can react with oxygen. You know it that nitrogen can react with oxygen to form 5 types of oxides. N2O, NO, N2O3, NO2, N2O5 like this. But at a very, very high temperature, it forms NO. NO is nitric oxide. And this is the gas that is formed during thunderbolt. During thunderbolt ಅಂದ್ರೆ ಈ ಸಿಡ್ಲು ಬರ್ತದಲ್ಲ ಅವಾಗ ಹೈ ವೋಲ್ಟೇಜ್ ಕರೆಂಟ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗಿ ಏನಾಗ್ತದ ಏರ್ ನೊಳಗಿರೋ ನೈಟ್ರೋಜನ್ ಆಕ್ಸಿಜನ್ ಕಂಬೈನ್ ಆಗ್ತಾವ ಆಗಿ ನೈಟ್ರಿಕ್ ಆಕ್ಸೈಡ್ ಫಾರ್ಮೇಶನ್ ಆಗ್ತದೆ. ಇಟ್ ರಿಕ್ವೈರ್ಸ್ ಎ ವೆರಿ ವೆರಿ ಹೈ ಟೆಂಪರೇಚರ್ ಆಫ್ ದಿ ಆರ್ಡರ್ ಆಫ್ 2000 degrees Celsius. ಹೌದಾ in the atmosphere during thunderbolt this is the oxide of nitrogen formed. You can just note it. So nitric oxide is formed during thunderbolt. ಏರ್ ನೊಳಗೆ ನೈಟ್ರೋಜನ್ ಆಕ್ಸಿಜನ್ ಇರ್ತಾವ ಸಮಸ್ತ ತಾನೇ ರಿಯಾಕ್ಷನ್ ಆಗಿ ಅವು ಆಕ್ಸೈಡ್ಸ್ ಆಫ್ ನೈಟ್ರೋಜನ್ ಆಗೋದಿಲ್ಲ. ಬಹಳ ಹೈ ಟೆಂಪರೇಚರ್ ಹೀಟ್ ಮಾಡ್ಬೇಕಾಗ್ತದೆ. ನಾವು ಏರಿಗೆ ಹೀಟ್ ಮಾಡ್ಕೊಂಡು ಕೊಡ್ಲಿಕ್ಕೆ ಆಗಿಲ್ಲ. ಸಿಡ್ಲು ಬಂದಾಗ ಏನಾಗುತ್ತದೆ ಆ ಸಿಡ್ಲು ಮಿಂಚು ಬಂದಾಗ ಆ ಚಾರ್ಜಸ್ ಡೆವಲಪ್ ಆಗಿ ಏನಾಗ್ತದೆ ಹೈ ಟೆಂಪರೇಚರ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತದೆ 2000 degrees Celsius. ಅವಾಗ ಈ ಗ್ಯಾಸ್ ಫಾರ್ಮೇಶನ್ ಆಗ್ತದೆ. ಎಲ್ಲಾ ಗ್ಯಾಸು ಅದೇ ಟೆಂಪರೇಚರ್ ಫಾರ್ಮೇಶನ್ ಆಗಿರಂಗಿಲ್ಲ. ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್ ದ ರೇಷಿಯೋ ಆಫ್ ದೀಸ್ ಅಂಡ್ ಟೆಂಪರೇಚರ್ ಡಿಫರೆಂಟ್ ಆಕ್ಸೈಡ್ಸ್ ಆರ್ ಫಾರ್ಮ್. But this is the most stable oxide at a very high temperature formed during thunderbolt. Right? And now reaction with hydrogen. Nitrogen and hydrogen react to form ammonia. And in order to balance N2, so 2 NH3 I take, as there are 6 hydrogen, 3 H2 I take. Okay, so ammonia is the hydride of nitrogen. Okay, hydride of nitrogen. Hydride of nitrogen means a binary compound of any element with hydrogen, just like nitride, oxide, hydride. Okay, so this reaction, all these are gases, and it requires catalyst and should be carried out in a closed vessel under very high pressure. This side there are 4 molecules, 1 plus 3, and this side there are 2 molecules. So according to Lee-Chatelier's principle, idanna closed container olaga madabeku, and an equilibrium is attained here. Reactant side 4 molecules adava, product side 2 adava. So as pressure increases, according to Lee-Chatelier's principle, number of moles decrease. So equilibrium shifts in the direction in which yield of ammonia increases. So you go on increasing pressure, you get more and more ammonia, more and more yield of ammonia. And this requires a catalyst also. So iron and molybdenum were used as catalysts earlier, and nowadays iron oxide is used as catalyst, and potassium oxide is used as promoter. Nowadays these are replaced by iron oxide and K2O. Iron oxide acts as catalyst and potassium oxide as promoter. Under a very high pressure and a moderate temperature, this reaction occurs. We will discuss in details about the manufacture of ammonia by Haber's process. That is important for the examination part of it. Okay, so written this: the nitrogen and hydrogen react to form ammonia under very high pressure in presence of iron catalyst and molybdenum promoter. Now, but the uses of nitrogen, where nitrogen finds its important application. Nitrogen, as I've already told you, is used as an inert gas in packaging of the food article. Food packaged articles irtava, adrolageಲ್ಲ nitrogen fill up ಮಾಡಿರ್ತಾರೆ. The air inside the container is displaced by nitrogen because it is less reactive. It prevents oxidation and hydrolysis of the food articles. And nextly, it is used in metallurgical processes to provide the inert atmosphere for extraction of metals. Metals which are reactive, some metals which are reactive, when extracted in an open air, what happens? They react with oxygen to form the respective oxide. Metal, for example, magnesium, aluminum, extract mardi. Isolation of elements study madidilla. Reactive metals and extract madadaga high temperature oxygen jete react oxide agbiduತ್ತೆ. Adakke air should be displaced by nitrogen. Adakke ಏನು application ಇಲ್ಲ, to provide inert atmosphere in metallurgical processes. In the extraction of reactive metals, inert atmosphere is required, and there nitrogen is used. Liquid nitrogen is used as a refrigerant. Liquid nitrogen na refrigerant use ಮಾಡ್ತಾರೆ. Note ಮಾಡ್ಕೋಬಹುದು. Liquid nitrogen used as a refrigerant. Refrigerant ಆಗಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ರೆಫ್ರಿಜರೇಟರ್ ಹಿಂದ್ಗಡೆ ಏನೋ ಒಂದು ಟ್ಯೂಬ್ ಇರುತ್ತವಲ್ಲ, ಅದರೊಳಗೆ ಯಾವ್ಯಾವ ಗ್ಯಾಸಸ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ? ಫ್ರಿಯಾನ್ಸ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಫ್ರಿಯಾನ್ಸ್, ಕ್ಲೋರೋಕಾರ್ಬನ್ಸ್, ಆಮೇಲೆ ಲಿಕ್ವಿಡ್ ನೈಟ್ರೋಜನ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ. These are important uses of dinitrogen. Now moving on to the study of compounds of nitrogen. We will study about ammonia. We will study about oxides of nitrogen. We will study about nitric acid. Well, starting from nitrogen, ammonia is manufactured. Starting from ammonia, nitric acid is manufactured. And from nitric acid, we manufacture many fertilizers like ammonium nitrate, calcium ammonium nitrate. And starting from ammonia, we prepare urea, ammonium sulfate, ಅದ್ರೊಳಗೆಲ್ಲ use ಮಾಡ್ತೀವಿ. And now, manufacture of ammonia, very, very important. Note it. Manufacture of ammonia by Haber's process. Very important. Manufacture of ammonia by Haber's process. It is a fixed question. ಕೆಲವು ಕ್ವಶನ್ಸ್ ಡೆಫಿನೆಟ್ ಆಗಿ ಕೇಳ್ತಾರೆ. ಒಂದು 3 ಪ್ರಿಪರೇಷನ್ಸ್ ಅವ. ಹೇಗೆ ಸಾಲಿಡ್ಸ್ ಒಳಗೆ ಸಿಂಪಲ್ ಕ್ಯೂಬ್ FCC BCC ಅದ, ಹಾಗೆ ಕೈನೆಟಿಕ್ಸ್ ಒಳಗೆ ಫಸ್ಟ್ ಆರ್ಡರ್ ಝೀರೋ ಆರ್ಡರ್ ಅದ, ಹಂಗೆ ಇಲ್ಲಿ ಒಂದು 6 ಕ್ವಶನ್ ಅಂದ್ರೆ ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ಆಫ್ ಅಮೋನಿಯಾ, ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ಆಫ್ ನೈಟ್ರಿಕ್ ಆಸಿಡ್, ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ಆಫ್ ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್, 3 ಅದಾವ. ಅಮೋನಿಯಾ, ನೈಟ್ರಿಕ್ ಆಸಿಡ್, ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್, ಈ 3 ಒಂದು ಕೇಳಲೇಬೇಕು. 3 marks. So let's study how it is manufactured. Nodri kada. Need to draw a rough diagram, rough flow sheet of this. Here there is a compressor. Pressure is applied through this nitrogen, and through this hydrogen are passed into the compressor, and then the reaction mixture is passed into reaction chamber. Reaction chamber where we have the gauze consisting of iron oxide Fe2O3 plus K2O, and then reaction takes place. Mute your audios. N2 react to form NH3. Catalyst chamber. Reaction. I shall show you the textbook. Mute the audio.
कॉलेज में मार खा लिया हम मार खा दिखाओगे मां बंद के खाना पूरा कर भाई मेरे मेरा कुतरा ना गपो बकबो भवा भवा ना खुड़ी
Audio mute ಮಾಡ್ರಿ ಯಾರ್ದಾರ.
नमस्ते हाँ ये बुका कार्ड मातने सर गप से वो मसरे ने नो लेकर के ना गप उधर गो नहीं बुका हम भाई दे ये पंद्री क्या आवाज खाना भले तो मानो ये पंद्री क्या ये रिकॉर्ड साउंड हेलो
Who's that?
हेलो
See, these are two inlets for passing nitrogen and hydrogen. See, pure. Listen to me carefully. Pure nitrogen and hydrogen in the ratio of 1:3 by volume. You now 1:3 ratio na pass ಮಾಡಬೇಕು ಅಂದ್ರೆ 1 liter nitrogen pass ಮಾಡಿದಾಗ 4 liter hydrogen. They are subjected to compression here to about 200 atmospheric pressure. 200 atmospheric pressure. Ashtu high pressure apply ಮಾಡಬೇಕು. And then it is heated here. Here it should be heated to about 500 degrees Celsius or 773 Kelvin. 773 Kelvin. The hot mixture, the compressed gas is now passed into reaction chamber. Catalyst chamber consists of hot iron oxide and potassium oxide. Okay? Here actually the reaction takes place. Hydrogen will react and ammonia is formed. But at this temperature and pressure, only 15% of the reactants are covered in products. But 15% ಅಷ್ಟೇ react ಆಗಿ ammonia ಆಗಿರ್ತಾವೆ. Remaining 85% are unreacted because in order to react completely, it requires a very high pressure. ಬಹಳ ಹೈ ಪ್ರೆಷರ್ ಬೇಕಾಗ್ತದೆ. 200 atmospheric pressure ಗೆ 15% ಆದ್ರೆ ಅದು 300 400 1000 atmosphere ಮಾಡಿದಾಗ 85% ಆಗ್ತದೆ. ಹೌದಾ? Moderate temperature ಇಷ್ಟೇ ಬೇಕು. ಅದಕ್ಕೆ ಟೆಂಪರೇಚರ್ ಇಂದ ಬಹಳ ಎಫೆಕ್ಟ್ ಆಗಲ್ಲ. ಪ್ರೆಷರ್ ಇಂದ ಹೆಚ್ಚು ಎಫೆಕ್ಟ್ ಆಗ್ತದೆ. According to Gouri principle, in this side there are 4 moles and this side there are 2 moles. So 200 atmosphere apply ಮಾಡಿದಾಗ ಇಷ್ಟು ಪರ್ಸೆಂಟ್ ಅಮೋನಿಯಾ ಆಗಿರುತ್ತದೆ. ನೀವು ಅನ್ಬೋದು 200 ಇನ್ನೊಂದು ಎಷ್ಟು 1000 atmosphere apply ಮಾಡಲಿ ಅಂತ. We have to see that this vessel should sustain that pressure. ಅಷ್ಟು ಪ್ರೆಷರ್ ತಡ್ಕೊಳ್ಳೋ ಕೆಪಾಸಿಟಿ ಇರಬೇಕಲ್ಲ ಅದಕ್ಕೆ. ನಾವು ಬೋರ್ಡ್ ಮೇಲೆ ಹೇಳ್ಬೋದು 200 ಯಾಕೆ 1000 ಯಾಕೆ 100% ರೇಟ್ ಆಗಲ್ಲ ಅಂತ ನಾವು ಅಲ್ಲ ಇವೆಲ್ಲ ಬ್ಲಾಸ್ಟ್ ಆಗ್ಬಿಡುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ರಿಯಾಕ್ಷನ್ ಆಗ್ತದೆ ಹಾಗೆ 15% ರಿಯಾಕ್ಟೆಂಟ್ ಹೋಗಿ ಪ್ರಾಡಕ್ಟ್ and it is passed into freezing chamber. It is freezing chamber. It is surrounded by the condenser, mixture of ice and salt. ಅದರೊಳಗೆ -33.3 degrees Celsius temperature. At -33.3 degrees Celsius, what happens? Only ammonia liquefies. The product ಏನು ಬಂದಿರ್ತಲ್ಲ ammonia ಅದಷ್ಟೇ liquid ಆಗುತ್ತೆ. What about the remaining unreacted nitrogen and hydrogen? They do not condense because they have a very low boiling point. Your boiling point is so -198 to -200. You gas ಆಗಿ ಉಳಿತು. Ammonia ಅಷ್ಟೇ liquid ಆಗಿದೆ. -33.3 degrees Celsius temperature take ಮಾಡೋದಿಲ್ಲ. Liquid ammonia ಬರ್ತದೆ. ಆ liquid ammonia ಮತ್ತೆ gas ಮಾಡ್ಕೋಬಹುದು. The unreacted gases, you react on 85% gases ಏನಂತ nitrogen they are recycled. ಮತ್ತೆ ಇವನ್ನ compressor ಗೆ pass ಮಾಡ್ತಾರೆ. Again they are subject to compression and along with fresh reactants they are subject to compression and they to react in a catalyst chamber. It is a continuous process. Nitrogen, hydrogen, pure formula 1:3 ratio volume ಒಳಗೆ ಪಾಸ್ ಮಾಡಿ ಕಂಪ್ರೆಸ್ ಮಾಡ್ಬಿಟ್ಟು atmosphere ಆಮೇಲೆ ಕಂಪ್ರೆಸ್ ಗ್ಯಾಸ್ ಅನ್ನು catalyst chamber reaction chamber ಒಳಗೆ ಪಾಸ್ ಮಾಡಬೇಕು. Here a moderate temperature of 773 Kelvin or 500 degrees Celsius to be maintained. 15% of the reactants are converted to ammonia. That ammonia along with the unreacted gases are now passed into freezing chamber where ammonia condenses into liquid at -33.3 degrees Celsius and it is out. The unreacted nitrogen and hydrogen are recycled. They were then reformed. compress along with the compress, then pass to reaction chamber. Okay. So the rough flow sheet of the diagram ಕೇಳ್ತಾರೆ ಇದನ್ನ ಬಹಳ ನೀಟ್ ಆಗಿ ತೆಗೆದು ಒಂದು 10 ನಿಮಿಷ ಟೈಮ್ ವೇಸ್ಟ್ ಮಾಡೋದಂತ ಫ್ಲೋ ಶೀಟ್ ಐಡಿಯಾ ಬಂದ್ರೆ ಸಾಕು ಏನು ಇಲ್ಲಿ ತೋರಿಸ್ತಾ ಇದೀನಲ್ಲ ಈ ಟೈಪ್ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಒಳಗೆ ಡಯಾಗ್ರಾಮ್ ಅದ ಬೇರೆ ಬೇರೆ ಟೈಪ್ ತೆಗಿಬಹುದು ಅದನ್ನ ಆಮೇಲೆ ನಿಮಗೆ ವಾಟ್ಸ್ಆಪ್ ಗ್ರೂಪ್ ಒಳಗೆ ಹಾಕ್ತೀವಿ pure nitrogen and hydrogen are passed to compressor where it is compressed to about 20 megapascal 20 megapascal or 200 atmosphere. Then it is passed into catalyst chamber where it consists of iron oxide K2O Al2O3 at 700 Kelvin or 773 Kelvin, and then the reaction, the product mixture is passed into freezing chamber where the ammonia condenses into liquid and the unreacted gases are again passed into this reaction mixture, fresh reaction mixture. Matte compress mada matte pass mada. So this is how ammonia is manufactured in large scale and it is asked in examination for 3 months. Equation 1 marks, diagram 1 marks, explanation 1 marks. Rough diagram ತೆಗೆದು ಆಮೇಲೆ equation ಬರೆದು ಇಲ್ಲಿ ಇಂಪಾರ್ಟೆಂಟ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಏನಂದ್ರೆ ನೀವೇನು ಬೇಸಿಸ್ ಅದರ ಬಗ್ಗೆ ಏನು ಡಿಫರೆನ್ಸ್ ಆಗಂಗಿಲ್ಲ ಈ ಕಂಡೀಷನ್ಸ್ ಏನದಾವ ಟೆಂಪರೇಚರ್ ಪ್ರೆಷರ್ ಕ್ಯಾಟಲಿಸ್ಟ್ ರಫ್ ಡಯಾಗ್ರಾಮ್ ಹಾಕಿ ರಿಯಾಕ್ಷನ್ ಬರೀ ಏನು ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಬರೀಬೇಕು ಮತ್ತೊಮ್ಮೆ ಹೇಳ್ತೀನಿ ನೋಡಿ a mixture of pure nitrogen and hydrogen in the ratio of 1:3 by volume or pass through compressor at 200 atmospheric pressure, and then they are passed into catalyst chamber consisting of iron oxide, potassium oxide or aluminum oxide where the temperature is about 500 degrees Celsius. 15% of the reactants are converted into ammonia. The mixture is then passed into freezing chamber at minus 33.3 degrees Celsius. Ammonia condenses into liquid and it is taken out. The unreacted gases are again recycled by passing through compressor. This much of explanation. The explanation na by heart ಮಾಡ್ಕೊಂಡು ಕೂಡಬೇಡ ಇದನ್ನ ತಿಳ್ಕೊಳ್ಳಿ ಮೊದಲು ಪಕ್ಕ ತಿಳ್ಕೋಬೇಕು ನೀವು ಓದ್ರಿ ಕೂತ್ಕೊಂಡು ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ನೋಟ್ಸ್ ಕೂತ್ಕೊಂಡು ಓದ್ರಿ ರಿಯಾಕ್ಷನ್ ಬರೆಯೋದು ರಫ್ ಡಯಾಗ್ರಾಮ್ ಹಾಕೋದು ಇದು ಹೆಂಗ್ ಆಗ್ತೈತಿ ಅನ್ನೋದು ಓನ್ ವರ್ಡ್ಸ್ ಬರೀಬೇಕು ಇಲ್ಲೇನು 100% ಗ್ರಾಮೆಟಿಕಲಿ ಕರೆಕ್ಟ್ ಇರಬೇಕು ಅಂತಲ್ಲ ನಾವು ಏನು ಮಾಡ್ತೀವಿ ರಿಯಾಕ್ಷನ್ ಕಂಡೀಷನ್ ಟೆಂಪರೇಚರ್ ಪ್ರೆಷರ್ ಕ್ಯಾಟಲಿಸ್ಟ್ ಪ್ರಮೋಟ್ ಎಲ್ಲ ಬರ್ದಾರೋ ಇಲ್ಲೋ ಈ ಟೆಂಪರೇಚರ್ ಅಷ್ಟಿದ್ರೆ ಸಾಕು ಬರುತ್ತೆ ಮಾರ್ಕ್ಸ್ ಕೊಟ್ಬಿಡ್ತೀವಿ ಅಲ್ಲ. So this is about manufacture of ammonia by Haber's process, and if you go to the word question paper, you will find that this question is repeatedly asked in examination for 3 months. So one year sir practice ಮಾಡಿಬಿಟ್ರೆ ಪರ್ಮನೆಂಟ್ಲಿ ನೆನಪಿಡ್ತವೆ ವೆರಿಫಿಕೇಶನ್ ಪ್ರಾಬ್ಲಮ್ ಏನಿದೆ. Moving on to the properties of ammonia. Ammonia, as you know, is a colorless gas with a pungent smell. Ammonia is a colorless gas with pungent smell, and it is highly soluble in water. Unlike nitrogen, nitrogen is almost insoluble, but ammonia is highly soluble in water. And you have learned in first period that ammonia has a pyramidal structure like this. It has a pyramid-like structure. There is a lone pair of electron. Actually, nitrogen ammonia is sp3 hybridized. Just like in methane, bond angle 109.5 degree. Similarly, the nitrogen three are bonds between nitrogen and hydrogen. And one of the orbitals contain the lone pair of electrons. As you know, The lone pair occupies more space than bond pair, and there is repulsion between lone pair and bond pair of electrons. That's why the bond angle is suppressed from 109.5 to 107 degree. Bond angle is 107 degree, and this shape is called pyramidal shape. In the shape pyramid like E type shape it has a pyramidal shape like this. Okay, here the bond angle is 107 degree. Till mele lone pair of electrons, and because of the presence of lone pair of electrons, it acts as a base, Levy's base, like equilibrium chapter kalti. Okay, ammonia is highly soluble in water, and with the reaction with water to form NH4OH. Ammonia gas ಅನ್ನು ನೀರೊಳಗೆ ಪಾಸ್ ಮಾಡಿಕೊಂಡು ಏನಾಗ್ತದೆ, with the reaction with water to form NH4OH. And NH4OH used it in laboratory in qualitative analysis. NH4OH use ಮಾಡಿರ್ತೀವಿ in the identification of groups of basic radical. First group OS plus dilute HCl, second group OS dilute HCl plus H2S, third group OS plus NH4Cl and NH4OH, fourth group, fifth group, ಎಲ್ಲ ಕಡೆ NH4OH ಯೂಸ್ ಆಗ್ತದೆ. third group ಕಾನ್ಸ್ಟಿಟ್ಯೂನ್ಸಿ ಏನು ಬರ್ತಾವ ಎಲ್ಲ ಕಡೆ NH4OH ಅನ್ನ as a reagent qualitative analysis ಹೆಂಗ್ ಪ್ರಿಪೇರ್ ಮಾಡ್ತಾರೆ, NH4OH ಬಾಟಲ್ ತಗೊಂಡು ಸ್ಮೆಲ್ ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗ್ತದೆ, that is the smell of ammonia. ಅದಕ್ಕೆ ಯಾಕೆ ಅದು ಡಿಕಂಪೋಸ್ ಆಗ್ತಿರ್ತದೆ, ಅಮೋನಿಯಾ ಸ್ಮೆಲ್ ಬರ್ತದೆ. And in the detection of NH4 ammonium radical ಟೆಸ್ಟ್ ಮಾಡಬೇಕಾದ್ರೆ 0 ನೋಡಿದ್ರೆ ಟೆಸ್ಟ್ ಮಾಡ್ತೀವಿ. Take the salt, add an OH and heat. Pungent smelling ammonia gas is evolved. Now about the strong solution liquid ammonia. Liquid ammonia is a very strong solution of ammonia is called liquor ammonia. Liquor ammonia. Highly concentrated solution of ammonia. Highly concentrated solution of ammonia in water is called liquor ammonia. ಆಮೇಲೆ ಇದನ್ನ ಎದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅಂತ ಹೇಳಿದ್ವಿ, as a laboratory reagent in qualitative analysis. ಆಮೇಲೆ in the detection of basic radicals, how it is used as a reagent. ಕೆಲವೊಂದನ್ನ ನೋಡೋಣ ಈಗ. Some metal salts react with NH4OH to form the respective hydroxides. They get precipitated as the respective hydroxides. For example, ZnSO4, MgSO4. You get NH4OH you prepare the original solution, OS from prepare original solution prepare ZnSO4, MgSO4 are soluble in water. This is NH4OH solution. What happens then? The respective metal hydroxides get precipitated. ZnOH twice. Zinc hydroxide precipitated. ZnOH twice in order to concentrate to NH4OH. And then ammonium sulfate is found as a byproduct. Another product is NH4 twice SO4. NH4 twice SO4. This metal hydroxide it is insoluble in water. That is why you get a precipitate. Downward arrow mark air indicate precipitate, solid act. Similarly, when MgSO4 and NH4 act, respect hydroxide, magnesium hydroxide. H4 basis. So magnesium hydroxide plus H4 plus H4. And you have done these reactions in laboratory in first PUC. When you are given MgSO4 ZnCO3, SO4 irbekante illa. MgCO3, ZnCO3. Prepare the solution in dilute HCl and then add H4H. Third group, fourth group ಒಳಗೆಲ್ಲ NH4H ಹಾಕ್ತಿರಲ್ಲ, ಅವಾಗ precipitate ಆಗುತ್ತೆ. Zinc hydroxide, magnesium hydroxide, precipitate. And from the precipitate, you will come to know that the given salt is ZnSO4 or Mg type FeSO4 ಇದ್ರೆ ಏನಾಗ್ತದೆ ನೋಡಿ FeSO4 plus 2NH4OH yes end product you are getting is FeOH twice ferrous hydroxide FeOH twice ferrous hydroxide plus NH4 twice and this is pale green in color ferrous hydroxide is green color ಇವೆರಡು white color and from the color we can differentiate but note ಮಾಡ್ಕೊತೀರಿ equations ಅನ್ನ write down the reaction ZnSO4 plus 2NH4OH ಬರ್ಕೊಡು ZnSO4 plus 2NH4OH arrow mark ZnOH twice Zn ಆಮೇಲೆ simple bracket OH twice downwards arrow mark indicates that it is a precipitate the white colored precipitate plus NH4 twice SO4 ZnOH twice plus NH4 twice SO4 and then you write this one MgSO4 plus 2NH4OH MgSO4 plus 2NH4OH arrow mark product ಏನು MgOH twice MgOH twice downwards arrow mark white precipitate plus NH4 twice SO4 so demonstrate all these in laboratory ಇವೆಲ್ಲ laboratory ಒಳಗೆ ಬರ್ತಾವೆ ಇವು demonstrate ಮಾಡಬೇಕು FeSO4 plus 2NH4OH FeSO4 plus 2NH4OH ಎರಡು solution ತಗೊಳ್ಳೋದು ferrous sulfate solution you take in test tube and add NH4OH solution we get green color pale green color instead of FeOH twice FeOH twice downwards arrow mark and green color precipitate so similarly so here when ammonium sulfate is added to different sulfate CuSO4 happens and ferrous sulfate ಆಮೇಲೆ MgSO4 ತಗೊಂಡಿದ್ದಲ್ಲ ಅದಕ್ಕೆ copper sulfate ಗೆ NH4OH ಹಾಕಿದ್ರೆ so you expect the same product you expect CuOH twice you get a blue color instead of the CuOH twice NH4 twice but when you have excess of NH4OH suppose excess of NH4OH ಹಾಕಿದ್ರೆ excess of NH4OH ಹಾಕಿದ್ರೆ reaction excess of NH4OH ಮತ್ತಷ್ಟು NH4OH ಹಾಕಿದ್ರೆ it forms a dark blue color complex CuNH3 times SO4 complex formation fifth ammonium sulfate and this is a solution blue color complex formation blue color solution blue precipitate blue precipitate it is blue color precipitate but when you add it in excess when you add NH4OH in excess it forms this complex ammonium sulfate and this is a solution so the precipitate form first dissolves in excess of NH4OH ಹೆಂಗ್ ಗೊತ್ತಾಗ್ತದೆ ಈಗ ಡಿಸ್ಟ್ರಿಕ್ಟ್ ಕಾಪರ್ ಸಲ್ಫೇಟ್ ಸೊಲ್ಯೂಷನ್ ತಗೋತೀವಿ ಬ್ಲೂ ಕಲರ್ ಸೊಲ್ಯೂಷನ್ ಇರ್ತದೆ ಅದಕ್ಕೆ NH4OH ಹಾಕ್ತೀವಿ ಮೊದಲು ಸ್ವಲ್ಪ ಹಾಕ್ತೀವಿ ಸ್ವಲ್ಪ ಹಾಕಿದಾಗ ಬ್ಲೂ ಕಲರ್ ಪ್ರೆಸಿಪಿಟೇಟ್ ಕೊಡ್ತೀವಿ ಆಮೇಲೆ ಹೆಚ್ಚಿಗೆ ಹಾಕಿದಾಗ ಎಕ್ಸೆಸ್ ಹಾಕಿದಾಗ ಆ ಪ್ರೆಸಿಪಿಟೇಟ್ ಬಂದು ಕರೆಕ್ಟ್ ಬಿಡುತ್ತೆ ಡಿಸಾಲ್ವ್ ಆಗಿ ಡಾರ್ಕ್ ಬ್ಲೂ ಕಲರ್ ಸೊಲ್ಯೂಷನ್ and it is due to the formation of this complex with ammonium sulfate complex coordination compound chapter coordination compound formation so ammonium sulfate solution is formed ಅದರಲ್ಲಿ ನಾವು ಡಿಫರೆನ್ಸ್ ಏನು ಮಾಡಬಹುದು ಈಗ ಐರನ್ ಇದ್ದಾಗ ಯಾವ ಕಲರ್ ಅಂದ್ರೆ ಗ್ರೀನ್ ಕಲರ್ ಕಾಪರ್ ಇದ್ದಾಗ ಬ್ಲೂ ಕಲರ್ ಜಿಂಕ್ ಮ್ಯಾಗ್ನೀಸಿಯಂ ಇದ್ದಾಗ ವೈಟ್ ಕಲರ್ ನಾವು about Uses of ammonia. Ammonia uses in what form ammonia is used. Ammonia is used in the manufacture of fertilizers. Fertilizers manufacture. The fertilizers, urea. Urea has a formula in NH4 twice CO NH4 NH2CO NH2CO urea. Then ammonium sulfate NH4 twice SO4. This is also used as a fertilizer. And then CAN, calcium ammonium nitrate. These are important fertilizers that are manufactured from ammonia, starting from ammonia. Ammonia and CO2 react to form urea. Ammonia and H2SO4 react to form ammonium sulfate, and calcium nitrate and ammonia react to form calcium ammonium nitrate. Well, nitrogen is essential for the growth of plants. Plants get nitrogen very essential. Nitrogen very. But you might think that there is plenty of nitrogen in the air. Air ಒಳಗೆ 78% nitrogen ಇರುತ್ತದೆ. Why can't they absorb nitrogen from the atmospheric air? No. Nitrogen is not directly absorbed by plants from air. Plants absorb only those things which are soluble in water. Near current alone water absorb. So air molecule nitrogen na absorb ಮಾಡ್ಕೊಳ್ಳಂಗಿಲ್ಲ. It is absorbed only by few algae. ಏನಂತ algae ಮತ್ತು ಪಂಕ್ಯ ಅವು ಮಾತ್ರ ಡೈರೆಕ್ಟ್ ನೈಟ್ರೋಜನ್ ಎಸೆನ್ಸಿಯೇಟ್ ಮಾಡ್ತಾರೆ. ನಮಗೆ ಮತ್ತೆ ಪ್ಲಾಂಟ್ಸ್ ನೈಟ್ರೋಜನ್ ಹೆಂಗ್ ಕೊಡಬೇಕು? The nitrogen in the air is converted into ammonia. Ammonia is then converted to urea, ammonium sulfate, calcium ammonium nitrate, and these are highly soluble in water. Called nitrogenous fertilizers. These contain high percentage of nitrogen, highly soluble in water. They will enrich the soil and make it more productive. Fertilizers andre nitrogenous fertilizers andre these contain high percentage of nitrogen and are highly soluble in water. They will make the soil fertile. ನೀವು ಸಾಮಾನ್ಯವಾಗಿ ನೋಡುತ್ತೀರಿ ಯೂರಿಯಾ ಹೆಚ್ಚಾಗಿ ಯೂಸ್ ಆಗ್ತಕ್ಕಂಥದ್ದು in hot climatic conditions like Bijapur, and for quick growing crops like onion, sunflower. ನೀವು ಅಷ್ಟೇ 3 ತಿಂಗಳ 4 ತಿಂಗಳಿಗೆ ಏನು ಬರ್ತಿರ್ತಾವಲ್ಲ ಆ ಕ್ರಾಪ್ಸ್ ಗೆ ಯೂರಿಯಾ ಯೂಸ್ ಮಾಡ್ತಾರೆ. But excess use of these like ammonium sulfate, calcium nitrate makes soil acidic. ಅದು ಯೂಸ್ ಮಾಡಬೇಕಾದ್ರೂ ಸಾಕಷ್ಟು ನೀರು ಇರಬೇಕು. ಬರೀ ಡ್ರೈಲ್ಯಾಂಡ್ ಒಳಗೆ ಯೂರಿಯಾ ಯೂಸ್ ಮಾಡಂಗಿಲ್ಲ. ಹೆಚ್ಚು ಮಳೆ ಆಗ್ತಿರ್ಬೇಕು. ಇಲ್ಲಾಂದ್ರೆ ಅವು ಪ್ಲಾಂಟ್ಸ್ ಎಲ್ಲ ಬೆಳೆನ ಸುತ್ತೋಗುತ್ತೆ. ಎಕ್ಸಸ್ ಫರ್ಟಿಲೈಸರ್ಸ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಸಾಕಷ್ಟು ಇರಿಗೇಷನ್ ಏನಿರುತ್ತಲ್ಲ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಇರಿಗೇಟೆಡ್ ಆಗಿ. ಸೊ ಅಮೋನಿಯಾ ಇಂದ ಇವೆಲ್ಲ ಫರ್ಟಿಲೈಸರ್ಸ್. And then it is used in the manufacture of nitric acid. Ammonia ಇಂದ ಹೆಚ್ಚನ್ನು ಅದು ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಒಳಗೆ ಬರ್ತದೆ. ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ಆಫ್ ನೈಟ್ರಿಕ್ ಆಸಿಡ್ ಸ್ಕ್ವಾಡ್ಸ್ ಪ್ರೋಸೆಸ್ ಅಂತಾರೆ. ಅಮೋನಿಯಾ ಇಂದ ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ಮಾಡ್ತಾರೆ. Okay, and thirdly, liquid ammonia is also used as refrigerant. Liquid ammonia no refrigerant ಆಗಿ liquid ammonia is used as refrigerant. Okay, as ammonia is having pungent smell, you might feel if there is any leakage in the refrigerant leakage ಅಂದ್ರೆ ಹೋಗುತ್ತೆ. ಅದಕ್ಕೆ pungent smell ಬರ್ತದೆ. These are some important uses of ammonia. And about the basic nature, basic nature. Why ammonia is base? Ammonia acts as a base because it can accept proton. This proton accept H3 plus H plus ಇದು ಯಾವ ತರ ಆಸಿಡ್ ಇರುತ್ತೆ. ಇಟ್ ಕ್ಯಾನ್ ಬಿ HCl, HNO3, H2S, proton acceptors are bases according to Bronsted law they concept. And it is a Lewis base. It is a Lewis base because it contains a low electron. It is electron pair donor, electron pair donor, and that is why it acts as a Lewis base. Okay, well, we'll discuss about oxides of nitrogen in the next class. If there are any doubts, to be clarified regarding this, you can note it down and ask. ಏನಾದ್ರು ಈ ಒಂದು ಹೇಳಿದ್ರೊಳಗೆ ಡೌಟ್ಸ್ ಇದ್ರೆ ಅವ್ರು ನೋಟ್ ಮಾಡ್ಕೊಡ್ರಿ, ನೋಟ್ ಮಾಡ್ಕೊಡಿ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಒಳಗೆ ಒಂದು ಕ್ಲಾರಿಫೈ ಮಾಡಿ. ಓಕೆ,
ಸೆಷನ್ ಮೋಹನ್ ಸರ್ ಸೆಷನ್
ಮೋಹನ್ ಸರ್ equations ಏನೋ reactions repeatedly ಬರೋದು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ. ಈಗಲೇ don't go on postponing the things. ಆಮೇಲೆ ಏನಾಗ್ತದೆ ಈಗ ಇನ್ನ ಈ ಕೊರೋನಾ ಹಾಲಿಡೇಸ್ ಎಲ್ಲಿ ಕಂಟಿನ್ಯೂ ಆಗೋದಿಲ್ಲ. ಈ ಜುಲೈ ಅಂತೂ ಇರೋದಿಲ್ಲ. ಮತ್ತೆ ಆಗಸ್ಟ್ ಒಳಗೆ ಇನ್ನೂ ಹೆಚ್ಚು ಸ್ಪ್ರೆಡ್ ಆಗ್ತಾ ಹೋದ್ರೆ ಮತ್ತೆ ಕಂಟಿನ್ಯೂ ಆಗ್ತದೆ. ಸಿಲೆಬಸ್ ಆಲ್ಮೋಸ್ಟ್ ಎಲ್ಲ ಇಲ್ಲೇ ಕಂಪ್ಲೀಟ್ ಮಾಡಿ ಬರೇ ರಿವಿಷನ್ ಮಾಡಬೇಕಾಗ್ತದೆ. ಏನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಇದ್ದು ಹೈಲೈಟ್ಸ್ ಒಂದಿಷ್ಟು ಪರ್ಸೆಂಟ್ ಕಡಿಮೆ ಮಾಡಿದ್ರು ಮಾಡ್ಬೋದು. ಅದು ಯಾವ ಪರ್ಸೆಂಟ್ ಕಡಿಮೆ ಮಾಡ್ತಾರೆ, ಎಷ್ಟು ಮಟ್ಟಿಗೆ ಮಾಡ್ತಾರೆ ಅನ್ನೋದು ನಾವು ಡಿಸೈಡ್ ಮಾಡಲಿಕ್ಕೆ ಆಗೋದಿಲ್ಲ. ಅದಕ್ಕೆ ಏನು ಹೇಳೋದ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ಸ್ ಸಿಗ್ತಾರೆ. ಎಕ್ಸಾಮ್ಸ್ ಮುಗಿದವಲ್ಲ, ಸೆಕೆಂಡ್ PUC ಮುಗಿಸಿದವ್ರ ಕಡೆಯಿಂದ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ಸ್ ಎಲ್ಲ ಇಸ್ಕೊಂಡು ನೋಟ್ಸ್ ಇಸ್ಕೊಂಡು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ. ಕೆಲವು ಇಂಪಾರ್ಟೆಂಟ್ ಡೆಫಿನೆಟ್ ಕ್ವಶನ್ಸ್ ಎಕ್ಸಾಮ್ ಅವನ್ನ ರಿಪೀಟೆಡ್ಲಿ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ. ಮೋಹನ್ ಸರ್ most